Imagine you're working on a big project, and suddenly, your program crashes because of a weird bug. Some part of your code accidentally changed a variable's value when it wasn't supposed to. Sounds frustrating, right? Well, Rust has a secret weapon against this: immutability. In this video, we're going to talk about variables, mutability, and how Rust's unique approach helps you write safer, more efficient code. By the end of this video, you'll understand why Rust is so strict about variables and how to use them properly. Let's dive in. All right, let's start with the basics. In Rust, we declare variables using the let keyword. Unlike other languages where variables are mutable by default, Rust takes a different approach. Variables are immutable by default. That means once you assign a value to a variable, you can't change it. Let's see this in action. This code looks simple, right? We declared a variable x, assigned it a value of 5, then printed it. But watch what happens when I try to reassign x to 10. Boom. Rust won't let us change x because it's immutable. And this is by design. Rust enforces immutability to prevent accidental changes to variables. But what if we actually need to change a variable's value? Here's where the mut keyword comes in. If you want to explicitly make a variable mutable, you just add mut in front of it. Let's modify our code and try again. Now, because we used mut, Rust allows us to change x from 5 to 10. Let's run the program. There we go. Now x can change. But here's the catch. Rust forces you to decide whether a variable should be mutable or not. This helps prevent unintended modifications and makes your code much safer. Think of it like a contract. If you don't declare mut, Rust assumes you don't want to change the variable, and it protects you from accidental modifications. Now, let's go a little deeper and understand why Rust enforces immutability. Unlike languages like Python or JavaScript, where variables are just references to memory locations, Rust deals with ownership and borrowing. We'll talk about those in a later video. But for now, just remember this. Every variable in Rust has a fixed memory location, and Rust ensures that memory is used safely. When we declare let x equals 5, Rust allocates memory for x and binds it to the value 5. If we try to reassign x, Rust doesn't allow it because that would mean modifying a memory location we declared as immutable. However, when we use mut, we're telling Rust that we intend to change this memory location, so it allows reassignment. This strict control over variables helps Rust eliminate entire categories of bugs at compile time rather than at runtime. That's why Rust is so safe. Now, what if I told you that you can reassign an immutable variable without using mut? Sounds weird, right? Well, Rust has a concept called shadowing, and it works like this. What's happening here? Instead of modifying x, we're declaring a new x that replaces the old one. This is called shadowing, and it lets us reuse the same variable name while keeping Rust's safety guarantees. Shadowing is useful when you need to modify a value without making the variable mutable. It's especially handy when transforming data, like converting a string to an integer. Just remember, shadowing creates a new variable, while mut allows modifying the existing one. And that's a wrap. Now, I want to hear from you. Do you prefer immutable variables, or do you like the flexibility of mut? Let me know in the comments.